having quite the time getting things to record right now.
Look,
So anyway,
Daddy,
so this is my attempt.
Daddy.
And this is Graham. Yeah, buddy, he's going to help me with my recording. But for this is the product rule. And this is going to be our big introduction to a way of taking a derivative. It's called the product rule. And this particular example is one that traditionally in the last couple days, you would have been able to take the derivative using the good old-fashioned, you'd simplify first. It's current and even the best method, frankly. If you're going to take this on, you take the derivative first, and then by simplifying it, getting it down to something a little bit easier, a bunch of little power rules that we could do to take the derivative. So here's all this simplifying I was talking about. I distribute, and so the good old-fashioned, if I take that 2x and I multiply it by each term inside there, you distribute it, and then you get this function, and then you'd say, all right, I'm ready for the derivative. And you take, the derivative of 2x cubed, 6x squared, and then 6x squared is 12x, and the derivative of negative 2x is 2. Done. That's it. We're done with the derivative. We'd move on. We can put in any x value and get the slope of a tangent line wherever you like. Now, there's another way to take the derivative of this function. We'll get the same result, and it's a type of rule called the product rule. I'll first give you kind of the rule that goes with it, and then we'll just use this example to show you that it works, and it takes maybe, I don't know if you could debate whether it's easier or harder, but first you got to know how it works. Now dx is the verb for take the derivative of. So if I'm going to take the derivative of some function f of x times some function g of x, okay, so it's like two different functions, the way it goes is you take the derivative of the first. So I'm going to label this first, this is d first, as I like to call it. And then the second one is g of x just by itself. It's just the second function, just like it was before. So here's the first, we'll call f of x first, and we'll call g of x the second function. So when I'm taking the derivative of the first, which is really bad handwriting, by the way, if I clean that up a little bit, d first, something like that. And then the other one's second unchanged. Like you notice it's g of x just by itself, plus the derivative of the second function, that's g prime here, so d second, okay, times then the first function unchanged. Now I know it sounds like you should be able to do it some other way for products, but this is the way it works out if I do the long way of the derivative with limits I showed you, a couple weeks ago. This is the rule that emerges that works for getting the accurate derivative. You can't take any shortcuts. You can never just take the derivative of one function times the derivative of the other function. That doesn't work. You have to follow this rule when it's two functions being multiplied. So don't try any shortcuts. You only get in trouble along the way. Okay, so we'll keep going. So here's how this works. Let's take our example. I have 2x times x squared plus 3x minus 1. I'll call the left function 2x at my f of x, and I'll call the right function g of x. Okay, I'm going to just go ahead and think of those as two multiplied functions. So to take the derivative of that, I'm going to take the derivative, and I'll do d first, which is just 2, times the second unchanged. So you'll see x squared plus 3x minus 1 unchanged. That's just the first part of it. Okay, I'll make little arrows kind of show you where those came from. Derivative of the first times the second unchanged. Then we'll take the derivative of the second part. Okay, do you see the second function over there? It's that x squared plus 3x minus 1. The derivative of that is just 2x plus 3. And then times the first function, which is 2x unchanged. So it always follows that pattern. It's the derivative of the first times the second unchanged plus the derivative of the second times the first unchanged. And then afterward, of course, you're welcome to simplify it. We should. So distributing the 2, multiplying the 2x plus 3 times 2x, and distributing that all out. We're going to go to the next page. I'll make it, we'll simplify a little bit further just to clean it up a little bit more. And then, by the way, here's just the retyping of that there. That's the stuff that we just finished with on the previous page. I'm just carrying it over. So here's what we got. Our derivative ended up being the expression you see there. That's after distribution, and we'll clean it up a little more. It's still the first derivative, and for our last, we'll be careful noting this is just the first derivative, and now I'm just cleaning it up. This is it, 6x squared plus 12x minus 2. And so nothing too fancy. We got to this by doing the derivative of the first times the second unchanged plus the derivative of the second times the first unchanged, distributed nicely. and then got all that stuff cleaned up. And then we did a little bit more cleanup of that result right here So I had it all tied up, and then we got this result. Now what's cool is that this matches what we did before when we simplified first and then took the derivative. So you remember that. Here's that piece right here. I'll kind of fast forward through this right to the end. See, we get the same result, different process. Okay, so I'm going to do this one more time on another example, and then kind of let you rip from there. Okay, next page, another little example, something pretty simple. 3x squared times 2x plus 1. I've got a first and a second function, and 6x is the derivative of the first times the second function unchanged that I need to write in here next. Okay, so it's derivative of the first times the second unchanged, plus the derivative of the second times the first unchanged. That process, you don't ever want to shortcut it. You always want to remember the product rule will always have a plus sign involved, and then you can simplify afterward. This is a perfectly good derivative. It'll get us the slope of the tangent anywhere we want.
Hard.
Yeah, do you agree?
Hard.
Yeah, it is kind of hard. I know. It's the product rule. We taught you that the other day.
Hard.
Yeah, we'll do that later.
Hard.
It's hard. Then the product rule we got right here is totally good. Simplifying is always helpful if it kind of cleans up your answer a little bit, but you know, it's not necessary. You can use it as is, simplify if you need to. I think I'll go ahead and leave it at that. So you guys know how to distribute and add that together. But derivative of the first, second unchanged, times the derivative of the second plus the first unchanged. Hope you enjoyed it. Email if you have other questions.